We are now going to look at ions. Again, I'm looking at magnesium, and you must look at its electron configuration. Magnesium has 2 electrons in the first energy level, 8 electrons in the second energy level, and 2 electrons in the third energy level. Again, notice that I highlighted with yellow for the 2 and the 8, and I have a green highlight for the 2 electrons that are in the third energy level. We again turn to the element on the table that has the same electron configuration as the first part of magnesium's electron configuration with the 2 and the 8. We say that magnesium starts off with the same electron configuration as neon. You'll see that neon is in the last group of the periodic table. This means that it's a noble gas. Noble gases have what we call the octet. And an octet means that there are 8 electrons filling the outermost energy level. What magnesium and any other element wants more than anything on the periodic table is to have the same electron configuration as a noble gas. This means that they'll become very stable. So one way that magnesium can do that is if it gets rid of those last 2 electrons, it'll be left with exactly the same number of electrons that neon has and have a complete outer energy level of 8 electrons. If that happens, magnesium will have 10 electrons with a negative charge, so 10 negative charges, and it will still have its 12 protons, which means it has 12 positive charges. It's going to leave it with an extra charge of a +2. Think about it. 12 pluses, 10 minuses, leaves you with 2 pluses. This is what we call an ion. An ion is an atom that has gained or lost electrons. By becoming an ion, magnesium now has the same electron configuration as the nearest noble gas. This happens to be neon. When it has a noble gas electron configuration, magnesium is very stable. Notice on your reference table there is an indication of what charge magnesium will have once it has established the electron configuration of the nearest noble gas. In this case, it's the +2. Upper right corner. Looking at chlorine, you can figure out what ion it will form in order to become like the nearest noble gas. Chlorine's electron configuration in its ground state is 2, 8, 7. And if I look at the upper right corner, I can see that there's a -1 up there, indicating that this is the ion that chlorine will form once it becomes able to have an electron configuration like its nearest noble gas. It turns out that chlorine wants to have the noble gas configuration of argon, which is closest to it. Notice that all I have to do is go from a 7 to an 8 in order to establish the electron configuration of a noble gas. So in order to get the nearest noble gas electron configuration, chlorine only needs one electron to be added to its structure. One more electron means one more negative. And there you have the -1 charge that chlorine will have once it has gained that extra electron and become like a nearest noble gas of argon. Chlorine now is going to have 18 electrons versus the 17 protons it originally has. So with 18 electrons, that's one more electron than it had when it was an atom, so it is now an ion with a -1 charge. And why did chlorine become an ion? Chlorine became an ion because it is more stable if it has the electron configuration of the nearest noble gas, argon. In this illustration, you'll see that chlorine has all of its orbitals filled with 2 electrons, except for that very last one in the 3p sublevel. So all chlorine really has to do is just gain that 1 electron and then have a completely stable orbital structure. So there you have it. 2 ways of looking at how atoms would become ions, and for a very good reason, in order to become like their nearest noble gas with a very stable electron structure.